As you probably understand, in this video we're gonna create Game of Life. In short, Game of Life is a cellular automaton created by Conway. The universe of the game is an infinite, two-dimensional grid of square cells, each of which is in one of two states, alive or dead. Every cell interacts with its 8 neighbors. At each step in time, cells perform transitions according to these rules. Any live cell with fewer than 2 live neighbors dies as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. And users do not interact with the game, but just set up initial configuration. So now we're gonna create an app for Android. The code is gonna be simple and may be ported to any platform. I use Android because I want to make it more interactive. And I use Java, even though I prefer Kotlin for Android development, because Java is C-like and well-known language, and I thought that it's gonna be much more understandable for people that are not familiar with Android development. I did not use any game engines intentionally in order to make it as simple as possible with minimal code base. So let's start. Go to IDE and generate empty Android project. Pick name and language and hit finish. Now create game view class. That's where we're going to describe logic of the game. If you're not familiar with Android development, in short, to make Android view, we need to extend view class and override and draw method. That's where rendering happens. Prepare 2 paint objects. We will get back to them later. Now let's declare a 2-dimensional array that's going to be our world, which value are going to be 0s and 1s. If its value is 1, then we assume the cell is alive. If 0, it's dead. Now create a init method where we need to initialize paint objects. In order to draw cells, we need paint objects. Since in this world there are going to be only black and white colors, we use only black and white paints. Now create game method that's gonna hold main logic of the game. Here we're gonna put 2 for loops that gonna scan our world cell by cell. We need 2 for loops because our world is 2-dimensional array or matrix, and inner loop gonna refer to rows and outer to columns. Inside inner loop we're gonna put neighbors count method that's gonna count how many neighbors current cell has. This method takes the position of current cell and scan every cell around it by shifting index from target cell to every possible direction. And if value is 1, which means cell is alive, we increment the neighbors count variable. And here goes rules of the game. So if cell is alive and if it has 2 or 3 neighbors, the value is gonna be 1, which means that it survives. If it has more than 4 neighbors, then it dies. And if the neighbors count is 1 or less, it also dies. Otherwise, if cell is already dead and if neighbors count is equal to 3, then it survives. Now we need to fill on draw method that's gonna draw our cells. So in our case, one cell is 1 screen pixel. So what it does, it walks through world array, and if value is 1, it draws black pixel. If it's 0, white pixel. Main coding part is finished, so now we can move to UI. In Android, we represent it with XML file, where we describe how the view gonna look like. So in short, here describe our newly created game view, its dimensions, positions, paddings and so on. and same for start button. Now in activity, and in Android activity represents single screen, we're gonna refer to views that we just described in XML file, so we can interact with it. Now we create click listener for start button, then gonna call start method, where we will trigger timer. Timer needed for execution of our world, so every 100 milliseconds it will trigger onTick method, and one onTick method call is equal to one generation of our world. Inside this method we call run method of our game view that we still need to create. This run method gonna call game method with all our logic, and invalidate, which triggers on draw method to render our view. And also we will add zoom view to our XML file, since pixels are very small, and as you remember we mapped one pixel to one cell and there are gonna be a lot of them, so I decided to add zoom view to be able to zoom the screen. And the last part are patterns. So patterns are a set of predefined cells that has its own behavior. There are a lot of them and you can easily Google it. I'm gonna show you some of these patterns. So probably the easiest one is glider that you've seen on video preview. As you can see, it's just hard-coded cell positions. So we still need to add setup pattern method to game view that will initialize world array with our pattern. And call it from activity class with needed pattern. Now we can run it and check how it looks like. And it failed. Let's see. Oh, I know what the problem is. The problem is that we need to save previous state of the world before moving to next generation, which is why we need temp array, where we're gonna hold new generation, and then at the end just reassign temp array to world array. That should solve the problem. Let's check it out. As you can see, glider is flying, or whatever it does. We can try another pattern. It's called glider guns. So all we need is change setup pattern method with another pattern. It looks pretty cool, but probably I've missed one cell somewhere. Anyway, that's how it should look like. I think you can Google initial configuration on your own and fix it. And also we can create world randomizer. For that we need to create random method, and in for loop we're gonna generate two random numbers in range from 0 to world size. And within that generated position, set up live cell. Let's see what we got. And start. Okay, it's enough. There is still a lot of stuff to improve. You can add like different colors for generations, add color for footprints of previous generations, add buttons and menus for different patterns, and so on. Feel free to play with it. All source code gonna be in description. And I think that's it. Thanks for watching.